host of Understand with the MGF technical panel with Roger Parker, Rob Bell and Dr. Ian Pogson.
Right, good afternoon everybody. My name's Ian Pogson and I know nothing about MGFs or TFs. And if I do need to know anything, I just pick up Roger's book. So you can ask me and I'll just say, well, look in Roger's book. Or you can ask Roger himself. For some years I've been employed by MG Rover, or at least he paid me to turn up to work. So I can tell you lots of interesting stories. I worked for Rob Oldacre, who was on the stage not long ago. I worked with Adrian Tucker-Peak, who was on the stage not long ago. Nick Fell, who was on the stage much earlier. He and I started as graduate trainees in Rover, in Land Rover actually, in 1980. So I go back a way, so I can tell you some of the history and what happened and why. I've got my own TF which I've rebuilt at the good offices of Mr. Flanagan over there, who's the on-site heckler from Yorkshire. So I think it's a fabulous car. It was engineered on a shoestring, as I hope you heard if you listened to Nick and the team earlier. It really was. I thought the budget was somewhere around £70 million. Nick said the figure was really starting with a 4. And if you think of a modern car today, there's a sort of modern car over there. The basic budget to go from a blank sheet of paper to a car on the road, fully tested, fully developed, fully safe, is about £1 billion of your great British pounds. I'll repeat that, £1 billion of your great British pounds. And it takes a lot of people who are much cleverer than me to do that piece of work. I've had the great pleasure of working with many of them in the buildings behind you at JLR and at Longbridge and at Canley and all sorts of Solihull places. So it is an expensive game, and these cars were done on a fraction of that budget. So no wonder in certain aspects they are a bit shitty. Let's face it, I'm sorry kids, but there are things about them that just drive you insane. But we love them. Mine's here today. I was the last chief engineer for the car under the Chinese ownership. I signed the boot of the last TF that was ever made to the memory of the great Brian Griffin, who was the first chief engineer for the car. Yeah, we do owe a lot to people like that. So here on the stage with me are people who really know what they're talking about. You've got a man who's done the famous Project Shed. And Roger, who with his fabulous son Matt, who did a great job fixing my car, by the way, fabulous welding skills, knows a lot more about the car than I do. So I can do stuff like tell you stories about the whole head gasket failure story, why it was and what really happened, rather than just the head gasket fell, because it's much more than that. But these guys can tell you much more interesting things. So. Rob, do you want to say anything?
Yeah, I'll just introduce myself. So I certainly have no car engineering background. I'm actually a doctor for my day job, so I play with cars much like yourselves, just as a hobby and something that we all genuinely enjoy. I agree with you, Ian. We all love these cars, and we all love their foibles. And I think that's why I really love my MGF, because there's so many things that I can improve.
Yes.
I can say, well, that's wrong. What can I do to fix that? And I'm sure that's something which we all enjoy doing. For my sins, I'm also on the MGF Register Committee. I'm the technical representative, and usually that's just based on experience. But I often call upon many of my friends and colleagues, including Roger and everyone else, just trying to work out solutions to various problems. And generally speaking, I think these are remarkably good cars for what we've just heard in terms of a development budget. They are astonishingly good for the amount of money. I remember the quip at the time was that the entire budget for the MGF was equivalent to what BMW would spend to tool up on a front bumper.
Yeah.
So it's so we're all driving around on BMW front bumpers, which is nice. So I'll hand over to Roger now.
Thank you, Rob. I've been around MG since 1960, so I'm a little indoctrinated with octagonal-shaped blood corpuscles, etc. But yeah, being in that area, I've done various things. The MGR V8 is based on a car that I built in the 1980s using Rover Group parts, and it just happened to be the right recipe at the right time when David Bishop was looking to project the new MGB bodies into a new car. But the RV8 was always a flag waving exercise, very limited, maximum 2,000 examples to raise the MG profile for the then forthcoming main MG new sports car, which of course was the MGF. Now I had no prior exposure to the F until a few weeks before the motor show in '95, and I had a very short passenger experience in one, which was really very exciting. And then subsequently, just after the launch, I was able to take one for a much faster, longer drive. And I remember on this dry island, picking up the speed, going faster and faster and thinking, is this car going to break away? And it just sums up the car. It was right from the first moment. It was just let down by a few rough edges. Now, in technical terms, of course, most people think one of those rough edges is more like a sharp knife, called a head gasket. But that was a very complex issue, way beyond the head gasket, and it's something that today has tainted the cars. It's a reputation that no longer is at the level it was in the late 90s and early 2000s. Cars that suffered, if they were repaired properly, didn't suffer again. And subsequently, the final release of the MLS gasket, the multi-layer steel shim gasket, which was done by Land Rover. It wasn't Land Rovers, it was a powertrain development. It's just that it took an awful long time for it to go from the sheet of paper to actually being available for cars. But that has reinforced the reliability factor of the K-Series engine. And in this month's MG Enthusiast magazine, there's the first part of a little tuning feature I've done on K-Series engines, where I say that they are still leading edge, although they are now 30 years old. What they deliver is absolutely superb, even if that car's horn doesn't agree with me. Anyway, we'll ignore that. It'll go off if it's set properly. It'll reset shortly. Thank you. Yeah, so the head gasket is an issue that today most people, if they're coming into a K-Series engine car, and obviously we're focusing on MGF and TF, should not have any major issues with. You will have other issues. Of course, you look at the original underfloor coolant pipes and mild steel. You could find that they would perforate within 5 years. Of course, today we've got stainless steel and have had for a number of years. So the upgrades like that, and stainless steel exhausts and various other things, really have taken some of those rather rough edges that were present on that very first MGF. Notwithstanding, of course, that MG themselves did a lot of updates, and of course the TF is a very good example of how that was upgraded. For example, the stiffness of the body was significantly increased, with the rear wing and the sill structures being made out of one pressing rather than two. Foam is injected into the sills in places, and the structural area around the windscreen. Little things like that actually make a big difference. So the car is really much better than the sum of its parts, and that's really where we're at today. And the number of cars here is a testament to how most people feel about it.
Especially when you think this is a 25-year-old car.
Yes.
And the rest, how many other 25-year-old cars would you expect to find a show where it's just full like this with those cars?
Yeah, exactly right. But outside of the MGF-TF world, in motoring circles, it's still not perhaps recognised as well as it should be. A number of years ago, I was asked by several publishers over a period of several years to write a book on MGBs, and I came back and said, well, they've already been written. What else can you write about apart from the same information with mostly the same pictures, and just do different words but telling the same story? Finally, I got one publisher who said yes to doing an MGF and TF book, and I'm pleased that the Crowwood Press took that on board, because I was able to do the first MGF TF restoration manual. And the idea is not as a workshop manual, it is there to add to the workshop manual information with hints and tips and lots of personal experiences on dealing with these cars, sorting the problems and getting a better car at the end of it.
Shall we start off with the head gasket issue? Because I think there's a lot to talk about. And I think, Roger, you've already said that actually it's much less of a problem now than it would have been, say, 10, 15 years ago.
Exactly.
But what do we think is the core cause of head gasket failure? I mean, I'm talking as somebody who's actually, despite having owned my MGF since 1996, I have never had a head gasket go on. And I've had numerous K-series power cars, none of them have had any of these problems. So I've always sort of scratched my head a little bit and said, why is everybody else's head gaskets going? So what do we think is the mechanism behind that? What is, and then we can maybe go on towards some of the fixes.
Yeah, I know Ian's got some very good insights into the manufacturer side of things, but what was very interesting historically was that there was a plethora of head gasket failures occurring after 3 years, when the cars were subject to a 3-year servicing, which included a coolant change, and then the gaskets were going like 9 pins falling shortly after the cars were returned to their owners after that 3-year service. And it was all down to correct bleeding of the cooling system, and I think Ian can add to that.
Well, you have to wind further back than that. When I was a young lad working at Gaydon in 1983, there was a car there called the ECB2 Annual Energy Conservation Vehicle, which was way ahead of its time. Typical Rover stuff, lots of clever people, not getting the recognition, doing a brilliant car, and then the politics and the government interference at the time said, no, we're not going to do that. And by the side of it, a 3-cylinder engine, which became the K-series and the sandwich construction stuff. So of course we started off with a 1.1 and a 1.4. And as I'm sure you'll probably all know, they were adequately cooled by dint of the fact that there was coolant all the way around the liners. The liners were, of course, spun cast iron. They were wet liners because there was coolant all the way around them. And then time moved on, and the cooling system remained effectively the same. The elastomeric gasket remained effectively the same. And the product plan at Rover got bigger and bigger, as Rob mentioned earlier and as Nick mentioned earlier. And there was very little money again, because of government interference and all the usual stuff, and British Aerospace and BMW and all that sort of nonsense. We were, of course, buying 1.6 engines from Honda, which were just great. The warranty on those things was just nothing. They had nothing wrong with them. I think there was one tappet that was a bit rattly in the first 100,000 engines that we took delivery of from Honda, and I used to test them at the facility next door. So then it was getting expensive buying these engines and gearboxes from Honda and Volkswagen and stuff. So we had to do something ourselves. So right, let's expand the K-Series engine, turn it into a 1.6. Oh, can we have a 1.8? Well, yeah, of course, we've got 1.8s in front of us now, and some 1.6s. And so you're still talking of a cylinder block with the same physical outward dimensions, but you've got to get more bore and stroke into it. So you're going to put more heat into it, and you can't any longer have a wet liner because they were really thick and nice and strong. And you've now got a damp liner, so the bore's expanded, the liner itself has got thinner, and it's more prone to distortion, and the computational fluid dynamics of seeing that actually happen in an engine is astonishing to see how the engine actually flexes. And so we ended up with an engine that was getting on the edge of its performance, really. But it had still effectively got the cooling system that was on a 1.1 or a 1.4. And the key with any engine cooling system is to get rid of the air. You've got to degas it, because air pockets heat up very, very fast and can get superheated steam, and that then drills a hole in the aluminium, and if there's any porosity in the aluminium, it blows it out. There's lots and lots of things going wrong. So what we've now got is a K-Series engine going into these lovely little cars, and also into Freelander. And you could more or less guarantee that a Freelander would die before it got to 30,000 miles. And there was a bloke working at Gaydon, who we'll call Bill for now because I can't remember his name. But he got water hammer in his domestic cooling system, heating system, sorry. And he got fed up with this water hammer at home, and he thought, that's air in the system, I've got to get rid of that. And because he's an engineer, he set to designing a thing which would work. And we got head gasket failure on the V8 engines of Land Rover at the same time. And that was because the cooling system was old and naff, and not up to the job, and didn't get rid of the air. And various other things came into play, like cost reduction. Oh, we can take this bleed valve off here and this bleed point off here and all that sort of stuff. And so the engine's under constant pressure. It's been stretched and stretched. It's going into heavier vehicles like the Freelander. It's going into cars like these that have just got the most appalling underbonnet cooling performance. These cars are just rubbish at it, as we all know. When BMW came along, they said, here, your car doesn't meet our underbonnet cooling standards. Well, that's funny, we said. It wasn't designed to do this, silly crows. Anyway, so there's all sorts of things going on. And Bill beavered away, designed this pressure release thermostat, which we know today, and fitted it to the Land Rover products for the V8, and happily their head gasket problems went away. In the interim, we were doing the KV6 engines at Longwich as well, and funnily enough, they've got a very modern head gasket to it, but we were never allowed to have the money to develop the head gasket for the 4-cylinder engines. It was just get the 1.6 out, get the 1.8 out as quickly as you can. And of course, it still carried the same cooling system as the 1.4 and the 1.1. And if you take that cooling system with the engine and plop it into your Freelander or your TF, you end up with a head gasket failure because you're not getting rid of the air. So Bill's idea from the Land Rover products, the pressure release thermostat, was read back to Freelander. And that's where it really started happening for these cars, because my car's a 2005 April car, a last car, and it's got a PRT on it. We knew what to do, we knew how to do it. It's not that we couldn't be asked to do it, we just weren't given the money, and we weren't given the opportunity by the owners of Rover at the time. And one day, am I boring anybody? No, okay. One day I got dragged to Solihull and put on the hot seat where the suppliers had sat, and a bunch of people in front of me saying, "Here, your head gasket keeps blowing. What are you going to do about your engine?" And I looked at the people that were in front of me, and they weren't as good looking as you. There were people I'd worked with at Longbridge. I said, "Just a minute. I know this game. I've been in this business a long time. Don't give me that we're going to throw rocks at the supplier business. You know what needs to be done. You know you need to sort your cooling system out," which is, of course, what happened on Freelander. So it's a complex story with a lot of background to it. It's not that we didn't know what to do. We did. We just weren't given the money and the opportunity. We got some very, very clever people at Longbridge. And so, again, I was dragged, because at the time I was working for Powertrain Limited, which of course had been owned by BMW for another year because we made the gearbox for the Mini and it's all very complicated. And I was dragged down to MG Rover and poked up by their quality director. He said, "What are you going to do about your head gasket?" Here we go again. It's got to be taken as a system. You've got to look after the system. This is a cardiologist sat next to me, Rob. You've got to look after the human body as a system. You've got to look after a car as a system. So, yes, you've got to do something for the head gasket, because we need a bit more beef up there. So now we've got a multi-layer steel head gasket. Right, now we've got to do something clamping the whole thing down a bit better. So we've got these higher rated through bolts that you can now buy. Fantastic. We need to fix the thing that they go into, which is the oil rail at the bottom. We need to beef that up. Right, we've done that. And then we need to put this pressure release thermostat into the system to get rid of the air. So if you do all of those things together and treat it as a system, then you can solve the problem. And I see a few LE500s about here. There's some Asbo orange LEs knocking around here. And to their very great credit, and I worked for them for 10 years, the Chinese did that. The first of the guys at Nanjing who really did know how to make cars, they did that job. And then Shanghai Automotive came along and thought, "Oh, we better do the same thing." So they did the same thing, and don't try and switch components between the two engines, because it doesn't always work. But the Chinese have done a fabulous job. I don't know of any head gasket issues on any TFs or MG6s at all. If anybody knows, come and see me later and I'll beat you up round the back, but I don't. The Chinese were really, really good. They fixed it. So that's a longer rambling discussion, but I hope I've done the subject justice. It is complicated, but now we've done it. And as the guys have said, it's not an issue anymore. You can go and talk to people like the people at the side here, and many of the traders at the back. Get the right bits, make sure you do get the right bits from a reputable manufacturer, but do it all, and that'll nail it. If you go and see somebody nice like Mr. Flanagan, he will do it for you. So yeah, just be careful, look after these cars, and don't forget, there's several bleed points you've got to do. If you've got to look at on your car, you've got the one in the radiator, you've got the one in the heater box, you've got the one on the engine coolant rail. So there's 3 bleed points. The one by the heater is it's really small, but because the heater is where it is, it's kind of too high really for the cooling system to get the air out of. The whole thing is compromised by its design, which is of course why we love it. So be careful out there and keep an eye on your coolant.
I just want to add something to that head gasket thing and treating it as a system. And the MLS gasket, as many of you will know, comes with an additional 12 thou thick steel shim that sits on top of the gasket. And a lot of people think they know better than the designers. And when this shim is supplied as a separate part, they choose not to fit it. Now, the reason it needs to be fitted is that with an MLS gasket you have 5 layers of steel, where previously the SLS gasket had 1. And the area that was previously filled with coolant between the head and block faces is actually considerably reduced. Now, what can happen under harder use is that that smaller volume of coolant can vaporize, and that acts as like a scouring pad and damages the head face surface. So the 12 thou shim that comes with an MLS gasket is there simply to protect the head face.
Just because I'm wary that probably some members of the audience want to ask a question, but I want to ask a question of you guys. We've talked a lot about the MLS. Can we fit MLS to any engine without any prior checks?
My answer is no. You want to have certain checks, such as the liner heights. They've got to be ideally 2 to 4 thou, although you will find different specialists have a thou here differences. But a lot of the 2004 built engines tended to end up with next to no stand proud. And then you can have a sticking plaster type of repair and use an SLS gasket, and it will last longer than the MLS gasket does before it leaks.
Right, enough head gasket stuff, unless anybody wants to ask a question. I'll give you a couple of tips, because I'm supposed to be an engineer. If it can't be done with leverage, can it be done with heat, either lack of it or excess of it? And can it be done with the right tool? So something that Chris really got me going on was taking your subframe out. Many of us have done it. Many of us have sheared off the heads of those stupid little fixings that are far too small for the job. Get down to B&Q, or the DIY stores are available, and get one of those propane blow lamps, or the modern equivalent, which is an electromagnetic heater. But get some heat onto any fixing that you have got to remove that's rusty and or has a locking sealant on it. Because if you get the bolt of that fixing cherry red, you will melt the thread lock glue, or you will simply crack off the corrosion that's taken place. It will just split a little, just enough for you to then start undoing it. If it starts to get tight again, don't keep winding, get the heat source out again, warm it up again, and ease it out. Yeah? Be careful doing things like using a big bar on high grade, high tensile suspension fixings, because all you'll do is rip off the head. So although as an engineer I would promote a bit of leverage, a bit of torque and a bit of heat, just be careful how you apply them. There's some absolutely essential tools you need, as I'm sure you'll realise, for these cars. Single hex sockets, deep ones, are just one of the best inventions ever. So yeah, just a couple of general tips there.
Just before we go on, just about those bolts, they do seem to collect water just where the shank goes through the subframe. Is there anything that we can do? Is it worth wrapping those up with a bit of marine grease as you're assembling it, or?
Yeah. When you're reassembling it, use something to protect it for the next time, which you hope won't ever happen. But yeah, that's certainly what I do. Yeah, absolutely. Make it easy for the next person.
Which should almost certainly be yourself. Be
yourself.
Yeah. First yourself when you didn't. Is there any questions from the audience?
Well, while we're looking for questions to come onto the stage, yes, I can see one on the left.
Tim,
on your left.
Your left.
But what we're,
we're working, but the range on this isn't very good, so you might have to come here. I've been told not to venture over this white line.
Right, yeah, I've got a VVC that's got the usual sort of clatteriness. Is there anything I can do about that? Short of replacing the engine?
well, you can replace the BBC, but it needs further examination because there's a lot of small, precisely machined components that the cumulative effect of just a little wear, which is usually a longer term issue that reflects perhaps oil changes, filter changes that have been a little delayed, shall we say, and that often leads to a small amount in each movement, which cumulatively creates enough movement for the mechanical clatter. But the guide I've always used for VVC's serviceability is that it often sounds like a diesel engine up to 1500 RPM, but if it quietens down after then, it's okay. It's when you've got the diesel clatter running beyond 1500 RPM that you then start having to look in detail inside.
So it was never intended to be serviceable parts,
No.
So obviously I've taken them apart and dropped them on the floor.
Is it something where there's an oil rail or something at the top? I'm not very K-series sort of aware, but is it possible that someone's, because I've only bought the car a couple of years ago, it's only done 25,000 miles, it had this issue when I bought it. Some other issues like bootstrap oil or something, doors need, they're probably glazed or something. But the VVC side of it, is it possible that this top oil rail, because I think people have used sealant, I don't know if it actually has a gasket, so I'm not going to work myself, is it possible to be oil starved, either through the oil ways being blocked, or is it possible, because again, the previous owner, I believe, didn't really drive it very fast, could the engine have done a lot of its miles, not being revved, therefore not having oil passing up to the top end of the, to the cam sort of mechanism?
Well, certainly if the head come off or if the top cam cover comes off and they're a little bit generous with sealant, there's always a risk of sealant getting into places it shouldn't do. But predominantly the issues are either there from word go, and there are issues that can occur. I've seen cracked elements of the internal VVC steel components virtually from new. I think Ian might have a better insight into the manufacturer and the change of suppliers of these components, but there were a few issues, but predominantly the main problems will be from the lack of good lubrication.
I probably shouldn't tell you this, and it won't help you at all, but engineering never signed off the VVC program at all. Marketing wanted it because it looked good on the brochures, and
Another backdoor product.
Yeah.
Actually, the VVC cams, I've noticed, when you take them apart, like how you're not supposed to, when you take them apart, they actually, they've got the little sliding blocks have got little letters on them. Is that because of they're graded, or they're particular sizes?
Well, I think that goes back to the fact that there was more than one manufacturer of the mechanisms. I think there was a change of supplier in 2004, wasn't there?
Yeah. And don't ask me how to explain how it works. I've seen the model, I've seen it explained in French, German, and with hand signals, and I still don't really understand how it works.
It is, but very well, yeah.
There were some very, very clever people there. It was great when he does.
Okay, we got another question. I think if you have a question would like to come forward. We can't get that far.
Good afternoon, gentlemen. I've just recently bought a freestyle BBC, which has been fitted with the Suplex suspension. I use the New Forest. The suspension's fine on good roads, A roads, motorways and that. Around the potholed forest, it really crashes out quite badly at times.
Mostly on the front, I would expect.
And occasionally the rear as well. So
Okay.
as if you're sat on a plank or all of a sudden you've got a front on.
Yeah, yeah.
Now, I discovered yesterday, so I've only had the car 3 days. I did a tyre pressure check before running up this morning, and they were a little bit low. So I've set the factory settings for 1.7 bar on the front and 1.9 on the back, and that has made a difference, which I found quite surprising. But I just wondered if there's anything that can be done in terms of maybe shock absorbers or that to even it out.
yeah, that's a complex issue, and I'll try and cover that. The issue of the hydrogas and earlier hydroelastic suspension is that primary damping is done within the displacer. The body of MGF and TF was never designed for a damper to be putting its loads into the upper mounts within the body. So when you look at MGF, the dampers have absolutely no compression damping at all. It's all on the rebound because the primary damping is done within the displacer. Now, when you take a displacer away and change it for a steel or coil spring, you have to introduce a degree of primary damping in the auxiliary damper. But you're very limited in what you can do because of the weakness of the body, and it will punch through if you have a hard setting. And that's something which a lot of owners, even with the hydrogas system still there, but they put adjustable dampers on and screw them up, or they let the hydrogas settle too far, so the shock loads going through the body simply punch the top of the damper through the damper mount in the body. So the Suplex system was developed with low primary damping just for stability, and the main damping was in the rebound. Now, unless you go down the road of following MGF cut car body preparation or using Mike Satter's reinforcement kit and welding into the top, you can't safely, certainly not safely for long term, put any stronger primary damping loads. Now, when you're coming to the noise that comes through, that can be something which is simply down to the two different systems. Now, with a hydrogas displacer, you have fluid and rubber diaphragms. So noise that is created within the suspension is damped out by the displacer, so it doesn't penetrate. Now, with the system you've got, you have a steel piston that is pushing into the canister where it's compressing the spring, and that canister is acting like an echo chamber. So small noises that you get developed that would previously not be heard are now being amplified. So that's one of the reasons. Now, another factor is that usually cars that have got a conversion will have done a fair few miles. And one of the aspects of the original suspension, where you've got the knuckle joints that sit in the top arm that then connect into the piston that goes into either the Suplex or the displacer, that can degrade, and you can find that the plastic which is contained within the recess in the top arm can actually start to break up. When that breaks up, that drastically increases the noise generation when you've got a suplex, or now what it's called, of course, it's X-part system. So have a look at those knuckle joints, because they are clearly good generators of noise if they're worn. I would definitely look at that, because if you've got wear in that, of course, it's going to give that amplified effect as well. So that's the first area to have a good look at.
Thank you very much. Thank you.
Good. Thank you very much there. Do we have another question? Oh, we've got one queuing up there.
Any thoughts on the introduction of E10 fuel? Should we pay any attention to that? Does E10 restrict your maximum power? I'm thinking if track day, do I need to go up to the E5 Super?
Yeah. History, and Ian will be able to confirm some of this, shows that within Rover Group, I think it was 1996 model year, that the first the view of future fueling envisaged things like ethanol, and the quality of the standard components from 1996 model year was actually compatible. Have you got a comment on that, Ian?
Yeah, because we've sold cars across the world, in crazy places like Mexico even, and in parts of the world like that, ethanol in fuel was quite common even in those days. So again, it's one of the things we were really rather good at, looking forward at new legislation and stuff like that, and taking account for it. So yeah, you're dead right.
I seem to remember that a number of the London Taxi Council also fitted Rover K series running on ethanol.
Some were, yes. Yeah.
So I think the fuel system on our cars are going to be fine.
Yeah,
and I think Land Rover says that actually Freelander with K series is fine. Yeah. So we're not going to run a problem with that. Your other question, I think, was about the fuel as a performance fuel for track days.
Yes, because you're looking at losing about 3.5–4% by going to E10, so it's oxidising that, so you're not got the energy in the ethanol fuel.
So it would be worth for a track day a tank full of E5.
Yeah, the stopwatch would notice the difference, but in reality it wouldn't.
Yeah.
But what will show up is that you'll think to yourself, that last tankful didn't last as long. You will use more fuel, but the beauty of the control system is that the engine will automatically correct itself to the weaker mixture. It's just that you'll use more fuel to go as quick.
Thanks.
Can I just pick up on that sort of loss of power? Because you see a lot of enthusiasts now converting to E85 as a fuel and getting more power out of their cars, with obviously with different ignition, presumably different fuel in that. So presumably the E10 is not necessarily the cause of the loss, but maybe just because the ECU is not adequately mapped for that particular fuel.
Exactly, because by introducing an oxidizer, you're weakening the mixture. So if you've got a fixed jet carburettor, you're going to be running a weak mixture, and a weak mixture won't start a cold engine, so you need choke. But with an engine management system with a three-way control catalyst, it does it automatically for you. So in that respect, that won't apply. But it's the fact that there's less energy, and consequently to go the same distance at the same average speed will mean that you will use more fuel.
So presumably, if you had it, imagine E10 is just going to get more prevalent. Yes.
Yes. Yeah.
So
I mean,
whether we need to go and speak to our tuning colleagues and say, look, can we get a remap suitable for E10 to claw back that performance, or even maybe get a little bit more performance?
I don't think E10 is a strong enough level to cause significant problems, but certainly if you start going to higher concentrations, like the fuel flex vehicles that are around, you'll definitely need remapping.
Mine's plans 1.9, built in December 1995. So there's no twin.
It's a 1996 model year build, so you're okay. That is, unless you put some cheap fuel hoses or other components that are not compatible. That's the problem, because if you buy a second-hand car that is a few years old, you don't know what quality of parts are fitted, and that can be a problem. Certainly for classic MGs, that's a big problem, but it would be also a problem for certainly MGFs. TFs not so much, because of course they wouldn't have been in the first zone where they needed to have that sort of replacements by the time ethanol resistant fuel components were commonly available.
Okay, well thank you very much, Dr. Ian Pogson, Dr. Rob Bell, and ordinary Mr. Roger Parker. Thank you very much.
Happy to be ordinary, thank you very much.
Thank you.